Hello, so in this video we're going to look through some integration by substitution examples. So let's suppose we have something like this, the integral of 1 over x plus 3 with respect to x. Now, if you know what you're doing, you could probably just do this directly and just do this through recognition, but I'm going to do it formally. So I'm basically going to say, well, okay, the thing which makes this awkward is this function on the denominator. I've got a fraction going on, this kind of looks a bit awkward. If it was 1 over x, that's straightforward, but in this case I've got 1 over x plus 3, which is a little bit more complicated. So I'm just going to say, well, okay, let u, or any variable you like really, equal x plus 3. So, okay, that means then that I can just replace this x plus 3 with 1 over u. However, I've got an issue, because at the moment, this is with respect to x. I've got a dx here, which means I'm integrating with respect to the variable x. But my function is now in terms of u, which means that I need to make a substitution or a replacement for dx. So, okay, in order to do that, I can probably differentiate the function that I let u equal. So u equal x plus 3, let's differentiate it. So I'll find du by dx, which is just equal to 1. Okay, that's what happens if I differentiate the function with respect to x, which means that if I want to find dx, just do a little bit of replacement, I can say that dx by du is equal to still 1 over 1. Okay, so just flip it upside down, which means that dx must be equal to du. Okay, so that means that I can replace that with du. Okay, so if I now integrate this function with respect to u, I can write this as the integral of u to the negative 1 with respect to u, and I realise, hang on a minute, that's simple and straightforward. Integral of 1 over u, well, it's basically the same as integrating 1 over x. I know a function which, when I differentiate it, gives me 1 over u. That's just simply the natural logarithm. So in this case, I have the natural logarithm of u, and then I must remember to add on my c because I've integrated it now. So if I replace my u with what I originally let u equal, which was x plus 3, then this is just simply the natural log of x plus 3 plus c. Okay, so that would be my final answer in that case. Okay, so let's have a look at this example, the integral between 0 and 2. So we've got limits, so we know it's a definite integral of 3x plus 5 all cubed with respect to x. So first things first, I notice that that's the bit that's making it awkward. I've got the 3x plus 5, and then I'm cubing the whole thing. If it was just like x cubed, that would be easy, but it's not. It's 3x plus 5 all cubed. So I'm going to let u equal my 3x plus 5. That's the bit giving me a bit of a headache. So I'm going to let u equal 3x plus 5. So therefore, in that case, my integral becomes, now in this case, I'm not actually going to consider my limits, okay? You can sort of convert your limits in terms of u, but in this case, I'm going to leave my limits off until the end, okay? So that basically implies that I have the integral of u cubed, because of course I replace my 3x plus 5 with u, but I must remember to also substitute my dx. So let's have a look. Well, I know that du by dx is equal to 3. That's basically just the derivative of that function with respect to x, which means that dx by du must be equal to 1 over 3. I just simply reciprocate my du by dx. So therefore, if I want to find dx, then it's just going to be 1/3 of du. I'm just going to rearrange this and treat it like a fraction. I mean, it's not a fraction, but it can be treated of as a fraction, okay? So therefore, dx is just going to be 1/3 of du, okay? So that's my substitution for dx just there. Okay, so therefore now if I pull out my third out the front, I can write this a third times the integral of u to the negative 3 with respect to u. So again, I'm just writing it as the form u to some power, okay? If I integrate it, I add 1 to the power, then I divide by that new power. So in this case, I get a third. If I add 1 to the power, I get negative 2. And I need to divide by that power. So if I divide a third by negative 2, I get negative 1/6. Okay, so I'm just going to write as negative 1/6 plus my constant of integration. So therefore, if I put it back together, this becomes negative 1 over 6u squared plus c. And of course, remembering that u was originally 3x plus 5, I end up with negative 1 over 6 times by 3x plus 5 all squared plus c. Now, I'm not quite finished because you remember that this whole thing was between the limits 2 and 0. So I'm going to put my limits back in at this stage. Okay, so put my limits in, so put my square brackets, and this is between 0 and 2. So first things first, I'm going to stick 2 in. So I'm going to get negative 1 over 6 times by 3 times 2 plus 5 all squared plus my c. So that's what happens if I stick 2 in. Then I need to take away what happens if I stick 0 in. So I get negative 1 over 6 times 3 times 0 plus 5 all squared and then I add the c. Now obviously at this stage I can just establish, well, the c's will just cancel, so that's the reason why I didn't have to write the c's in at the beginning, okay, because I knew it was going to be a definite integral. Okay, so what do I get? Well, I'm just going to do a bit more tidying up before I reach for my calculator. So this is going to become negative 1 over, okay, 3 times 2 is 6, plus 5 is 11, square it, that becomes 121. So what's 6 times 121? Well, 6 times 121 is 726. Then I'm going to take away a negative, so that becomes a positive. Then again, I get 3 times 0 plus 5, so that's just going to be 5. Square it becomes 25. Times it by 6, well, okay, that is just simply 150. So I get plus 1 over 150. So when I add those two things together, so I reach for my calculator, I get 16 over 3025, which gives me an area of about 0.005. Okay, so that's probably what I'm going to leave it as. Okay, so just remember, the whole reason why I'm sticking my limits in, so when I stick my limits in this place, is because I'm wanting to find the area between the function and the curve and the x-axis. So there's my x-axis, and then my function might look something like this. I don't know what it looks like. In fact, it's an x-cubed function, so it's probably going to look a bit like this, and it's a 1 over that function. So yeah, so it's probably going to look a bit like this. So let me get it right. That's my cubic function, and I'm finding it between 0 and 2. So there's 0, there's 2. I'm literally looking for the area between those 2 points, and in this case, the area is really, really tiny. It's 0.005. Okay.